All right, so here we go, 8.4. Number 5, a produce buyer for a juice company is buying apples. He makes a choice of either Michigan, New York, California, or imported. For this contract, he must also choose fancy, extra fancy, or ungraded. If each option has equal likely chance to be selected, find the probability of the following event. Apples are imported. All right. I think a lot of the battle for this next exam is going to be which tool to use. So the last one, the quiz question we just did, it was Venn diagram. How are you going to recognize when to use the box with the circles, the Venn diagram thing? Well, if they list a couple characteristics, right? It was, what was it? I already forgot. It was, liking TV or books, right? So if it's strawberry pie or chocolate pie, or what if there's two characteristics? Now this one is not two characteristics, it's several states. What am I talking about? Several conditions. The juice is buying up, or the juice company, he makes a choice of either Michigan, New York, or California, or imported. That's a choice, that's a selection. You know what that means you want to use? Tree. You want to use a tree. And what do I mean a tree? I mean there's going to be branching, right? So the first choice on the apples is they can come from Michigan, New York, California, or imported from out of the United States. Right? So an apple, the first branching, right? This is like flipping the coin. Remember how we did that with heads or tails, heads or tails? There was every time you do an action or make a choice, that's a branching. Right? That making sense? Like when I get dressed, I pick a pair of pants, I pick a shirt. There's several pants, there's several shirts. Lots of different outfit possibilities, right? That's what we're doing here. The apple comes from one of those four places, and then it has both characteristics. It's also either fancy, extra fancy, or ungraded. So it's 3 options coming off each of these. Does that make sense? It's fancy, extra fancy, or ungraded. Fancy, extra fancy, ungraded. Fancy, extra fancy, ungraded. Fancy, extra fancy, ungraded. See all the possibilities? And so then at the end of each branch, what do you have at the end of every branch? A leaf. Haven't you seen a tree? I'm sorry, I'm just joking around. At the end of every branch, we're going to have the results of whatever fall in that direction would be, right? So if I went this way, if I went Michigan, and then F, whatever F is, fancy. So this would be Michigan fancy type of apple. The next one's going to be Michigan extra fancy. Michigan ungraded, is that what it is? Yeah, ungraded. Do you see how I got those 3? Let me slow down so everybody see what I'm doing. Why am I using a tree? Because there's a decision and another decision. Or options and then more options. That's what it is, right? Decisions, each one having several options. That's when you want to do a tree. Or you could do a New York apple, fancy. New York, fancy. Or New York, extra fancy. Or New York, ungraded. Next, we could have California fancy, California extra fancy, California ungraded, and finally imported fancy, imported extra fancy, imported ungraded. There's actually 4 times 3, 12 different types of apples, aren't there? Right? Because there's 4 places and 3 types for each of those places. All right, now we're ready for their question. Notice I haven't even really looked at their question. What is their question? Find the probability the apples are imported. So it's probability, right? Now, remember, probability always means whatever number over the total. Right? Probability always has total at the bottom. Total. So first off, what's the total? Can you tell me what the total is? 12, right? Everybody, there's 12 total options here. 12 different types of apples. Right? With me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different types of apples. How many of them are imported? Those 3. Imported fancy, imported extra fancy, imported ungraded. 3 out of 12. That's the probability. See how we always do probability? And then how do we reduce that fraction? Divide by 3, top and bottom, 1/4. Done. That's the answer. So the chance you're going to get an imported apple is 1/4. And that makes sense. Really, you might think, could we just come back here and go, look, there's 4 times, imported is 1 of the 4. Yeah, you're right. Now that we've done all that, that would have been easier. But I want to give you the whole game plan that'll always work, even with harder questions. So you make that tree. How do you know? Again, how do you know you're supposed to make a tree? It's a lot of that. You want to be able to read a word problem and go, that's a tree, or that's a Venn diagram. How do you know it's a tree? 2 decisions, each having options. Where it's from, and then fancy, extra fancy, or great. Right? 2 different qualities. Right? On that. Each having several. Yeah, you might think, well, Mr. In the last one we had 2. I would think if I was you, I'd be thinking the quiz we just did had 2 qualities, you know, TV or books. How'd you know? Yeah, but there weren't several options. It didn't say you like sitcoms or mysteries or sports on the TV, or you like mystery for books. You like mystery novels, or it didn't give me like several options for the books and several options for the TV, did it? It just said TV or not, books or not. So that's Venn diagram. Everybody see the difference there? That was just TV or not, books or not. Whereas here it's like several different options. That's tree. Need the branching for that. That's the tool that'll do the job. All right. Stop me if you have questions. All right. Mathematics faculty at a college consists of 4 professors, 7 associate, 4 assistant, 12 instructors. 1 faculty member is randomly selected. Find the probability of choosing a professor or an instructor. All right, give that a try. I don't think you don't need to make a tree here. Why? How do I know? It's not one decision that leads to another. They're not connected in any way, right? Whereas the last one, it was the apple. Here, let me say it this way: the apples had both characteristics. The apples had where they're from, California, New York, whatever, and then whether they're fancy, extra fancy, or whatever. Right? Whereas these are unrelated. You're either a professor, an assistant, associate, or an instructor. There's no connection. It isn't one thing, then the other. So probability. Let's start with the bottom. What goes in the bottom of every probability problem? Total. What's the total? Whatever 4 plus 7 plus 4 plus 12 is, right? 27? 27. Okay, that part's good. So what goes in the top? Professor or instructor. 4 and 12. 16 out of 27? Is that reducible? I don't think it is. You can't divide anything on that, huh? We're done. So that one's a little more straight ahead. See how it's different than the tree problem that we just did, the apples. Because these are not related. It isn't like you do one thing, then you do another, like the apples were. They were from a state, and then they were graded. Fancy, extra fancy, whatever. Both things applied to every apple. That's not the case here. These are separate. Good. Okay, so P of Z is 0.42, P of Y is 0.40. That's that. Find all different kinds of things. All right. So take this Venn diagram. Let me just draw it. Let me do this. Here we go. So, and then I'll just do a big Venn diagram in the middle here for you. This will be Z and this will be Y. All right, give it a try. See if you can fill. Remember, there's 4 sections in a 2-circle Venn diagram. See if you can find the numbers in all 4 sections. Yeah, same thing. You have to add it to 1.0. Yeah, the whole box has to make 1.0. So if you have everything else except the outside, just add these up and subtract from 1.0. Because 1.0 is decimal same as 100 percentage. Right, you get to build, yeah, that's just. Yeah, I don't know the numbers off the top of my head. That seems a little big to me, though. Yeah, these up. Okay. Oh, well, you didn't use the decimals. They have decimals, which is fine. If you're not going to use decimals, then you need to use. Okay. Yeah, and subtract from 1. Yeah. So, there you go. But you can skip all the decimals and then just do 100 instead of 1. Are we doing good? So where do we start? What fact gets us going? Yeah, there's one in the middle, huh? The overlap is 0.16. Right? Then we can backtrack. The z is 0.42, so if I take 0.42 minus 0.16, I get something I don't know. 26? Is that right? 26, 36, 40. Yeah, 26. So now those add up to make z 0.42. Did y'all see that? And then and then we do the z is 0.40. So this, and this together have to make 0.40, don't they? I mean the y. Did I say the z? The y is 0.40. So that means these two sections that are together the whole y circle, right? They are together the whole y circle. And they're telling me right here the whole y circle is 0.40. So I got to take 0.40 minus 0.16. That'd be 0.24. So this is 0.24 right there. See how the whole y section now adds up to 0.40, the whole z section now adds up to whatever those two totals are, 42, like they're saying, and the middle is 0.16. So we've made it true. And now, how do we get this outer edge that out here? That comes from, remember, the whole box adds up to 100%, which I hope you know is the same as 1.0 decimal. We can either do this whole problem in percentages, or we can do the whole problem in decimals. Those are two languages to say part of a whole, aren't they? Right? So I'm doing it in decimals, so I'll continue with decimals. So that means I add these up. So I'm going to add up 0.26, 0.16, 0.24. Is that 66? 5, 6, yeah. And then 0.66 from 1 is 0.34. So out here must be 0.34. Now I've got all 4 sections in my Venn diagram. I'm ready to answer any question they want to ask me. Once you've got the whole Venn diagram, then turn your attention towards answering the questions. Here we go. So here comes the first question. Probability of that. So try that. Let me let you do that on your own. I'll give you a second to do that. See if that's making sense to you. What is the U turned over? I guess I assumed that up here. The U turned over means overlap, right? That's what I'm trying to how to keep. U turned over is overlap, right? And so this means overlap of, and what's the little mark on the Z and little mark on the Y mean? Yeah, so that's not Z overlapping with not Y, or opposite, right? Not in Z territory, overlapping with not in Y territory. See if you can. So notice that's going to be one or more of these sections. You got to go through and you got to ask yourself, is he included? Is he included? Is he included? Is he included? Which ones are included? Add those up, the ones that are included. Overlap is a way of saying and. Well, how about both? That's a way. Both. That's a better way. Because and can be confusing. Yeah, I won't bug you with this. Both. Both would be a better way. Oh, that's what overlap means. You're in both, huh? So that means you're both not in Z and not in Y. That's what overlap means. Both. So let's go through it. How about this 0.26 right here? Is he... If I'm standing right here, how about this to me? Here I am. I'm feeling artistic today. There I am. Pretty good, huh? So there I am. If I said, hey, you, me, right here, standing right here. You, are you both not in Z and not in Y? No, I'm in Z. So he's not included. Forget that. How about right here? Hey, you, standing right there. Are you both not in Z and not in 1? No, I'm in both circles. Okay. How about you standing right here? Are you both not in Z, so far so good, and not in Y? Oh, no, I'm in Y. Nope, not that one either. How about out here? Hey, you, standing right there. Are you both not in Z and not in Y? Yep, I'm not in Z and not in Y. Then you're my baby. You're the one I'm looking for there. Point 34. Does that make sense how we figured that out? Getting the hang of the logic of the Venn diagram? Questions I can answer? Want to try the next question? Let's try that. Here's B. Try that one. Now, what does the U turned up mean? Unite. Put them together. Either or. Instead of both, it means either or. How about that? Is that helpful? So here, I'm making a mess here. So this part A came out 0.34. We just did that. Part B now. Let me be real clear. So this symbol means both and. The U turned over means either or. Is that good? Both and versus either or. So the regular U means unite. It means unite. This other one, the red one up there, means overlap. Everybody good on getting the hang of the two terms? So the U turned as a normal U means unite. Either or. So unite. Not Z. Either not Z or not Y. That's what it's saying. Can you read my scribbles there? I'm going to write that again. That's pretty bad. Even for me. Either not Z or not Y. That's what this is saying, huh? Either not Z or not Y. So do put little people in there and ask them, hey, are you so or just if you can, you don't have to, if that helps, but whatever, do whatever you want. Can you do it? Are you able logically to look at this and say, all right, how about that one? Is he either not in Z or not in Y? No. It's not in Y. So he's in. Right? Get the idea with the either or. Be like we say, hey, there's a new scholarship for Fresno State. Free tuition all your years for your bachelor's degree. And if you get it, and everybody who meets the eligibility gets it, the eligibility requirement for this scholarship, you have to have either grown up in Fresno or been to the moon. Now, it's a good thing I didn't say and. See the huge logical difference between or and. If I said grew up in Fresno or been to the moon, as soon as you heard grew up in Fresno, I assume most of you grew up in Fresno. I don't know, maybe some of you didn't. But if you grew up in Fresno, you're in. Who cares what they say? If they say or, stop listening. Or you're a Martian. Who cares? I'm at the first one. And they said or. I'm in. Right? Or means either one. But if they say grew up in Fresno and, you better keep listening. Because you got to meet that one and the other one. Been to the moon. Oh no, I'm out. Right? So big difference. So this is either or. Either you're, so you point 26, either you're not in Y, yeah, I'm not in, here's Y, and I'm out. I'm not in Y, or, done listening. Already met the first condition. I'm not in Y. How about this point 16? Point 16, you're either not in Y, no, I am in Y. Or you're not in Z, no, I'm in Z too. No, I'm not, sorry, I can't get that scholarship. How about you, point 24? You're either not in Y, no, I am in Y. Or not in Z. Yeah, I'm not in Z. Well, you're in too. How about the point 34 out here? You're either not in Y or, yeah, he's in neither. He's doubly good. He's been to the moon and grew up in Fresno. He can really get that scholarship. Right? So it's all three of those added up, isn't it? It's point 26, point 24, point 34, whatever that is. 84? Point 84. That making sense? This is hard for people. Now you really need to do this yourself later. I'm prompting you with all the right questions. You know, you ever had that experience? This is really what's happening now. I've had experience where I'm in class and it makes sense. I've had experience where it makes no sense too. But I've had the experience where it makes sense. I go home, do the homework on my own, and I'm like, what did that teacher say? What did they do? How'd they do that? It's all of a sudden, it's totally different. This is one of these cases. I'm prompting you with the perfect questions, but you need to learn to do that for yourself. That whole either or, that's not easy to learn to do for yourself. Try this later. Don't say to yourself, oh, I got it, because you follow what I'm doing now. I'm perfectly prompting every question. You need to do that. I need to help you, but you need to do that for yourself later. You need to try these on your own and really try that out. There's a world of difference, especially when it comes to this. I'm prompting just the right questions. So try the next one. Yeah, maybe I'll do no prompting. Just try it on your own. See how good you're doing. Just try it on your own with no prompting from me. Once you got an answer, then I'll do it. So we start fresh with each question. Get rid of all my marks in there. So you can come up with an answer. Okay, I'm going to dive in. So what part of what I want to do is I want to not mislead you by my lecture. And I've had many students say to me over the years, Mr. Tarrant, I understand it perfectly when you're up there striving it, and then I try it in the homework and the test, and I can't do it at all. So I don't want that to happen for you. So that's part of why I'm giving some time is so that you see where you're really at without me prompting, right? So you should already be done with the problem. If you really understand this stuff, that's all it takes. That's all the time it takes to do the problem. So take note to self. How good am I really doing, and how much do I need to practice? So now let me dive in. So what does it say? Not Z, either. It's an either or, isn't it? Because of the U turned up. Unite. Unite means everybody together. Either or, right? Unite up here. It's either or. Either not Z or NY. Huh? Either not Z or. So which ones are not Z? This guy and this guy are not Z, huh? Either those or anybody in Y, right? Either anybody not in Z, that's these two, or anybody in Y. Who else is in Y? This. It's those three added up. See how quick that is if you understand? Yeah.
It says there in Z, not in Y.
What's that?
It said not in Z.
Everything not.
See the little mark on the Z there? That little mark means not.
I thought you were on D then.
Oh, okay. Yeah, no, I'm on C right now. Yeah, we'll get to that one. Yeah. Yeah, good so far? So not in Z, either not in Z or in Y. So it's those three added up, 0.16, 0.24, 0.34, whatever that is, 58, 74? 74 on that. Is that making sense? Now, let me change it. What if they'd had the U going upside down instead? Overlap. How would I have done then? It's still not ZY, but now it would be overlap, which means both. You can't do one or the other. You got to do both. You can apply for the scholarship. You've been to the moon and grew up in Fresno, right? Got to do both. So then I would look and go, okay, how many are not Z, these two? And how many are in Y, these two? How many are both? 0.24 only. Everybody see that? It would be 0.24 only in that case. That's the only one that's both, not in Z and in Y. See that? So in general, overlap are going to be much smaller answers because you got to do both. Just like if the scholarship says you got to have been to the moon and grew up in Fresno, there's going to be less people than if they say been to the moon or grew up in Fresno. Much more could get the scholarship, right? And is going to be lower number. Be thinking some low answer for and, both and. Whereas unite is going to be bigger answer, several things added, usually. Make sense? Is a way of thinking? Okay, try D. So you can do on D there. Okay, so it says you're in Z, you're both. This is a both and, isn't it? This is the U-turn to overlap. Both in, overlap means both. Both in Z and not in Y. So who is in Z? These two. Right? These two. And who's not in Y? Who's also not in Y? Only that. Point 26, done. It's just one section. The overlap is usually less stuff because you got to do both. Does that make sense? Good? Get more comfortable?
What the 3.4?
Yeah, so the first condition is you've got to be in Z.
Yeah.
So he's not in Z. Yeah, so the first condition says you got to be in Z. So I was already just down to these two. These two are in Z, right? The point 26 and the point 16. They're both in Z, and you also got to not be in Y. So that's why it was only the point 26. But I'm prompting it for you. Are you getting that? Are you able to prompt on your own? This takes practice. At least that's been my experience in the past. People have a lot of trouble. A million of them. And you just watch me do problems without any understanding. So, all right, let's try this one. This one's harder. Let me do this one with you. This one has an extra wrinkle. Let me show you. So start the same. We got Z, we got Y. That's all the same. But notice what they don't give us. Do you see what they don't give us? That they normally give us? Where are we going to start? There's no overlap. So they never gave us an overlap? Anywhere? That's hard. What do you do when they don't give you an overlap? Just give up. No, I'm kidding. You got to do something tricky. I'm trying to think what would be the easiest way to say this. Yeah. So basically the deal is the union is going to be Z alone plus Y alone minus the overlap. Yeah, that's a formula you need to know. I'd put that on my 3x5 card. So this is for use when no overlap given. When there's no overlap given. Why? I don't want to just give you a formula without any meaning at all. So I'll let you copy that down, and then I'll show you that it's true. What if I had 3 people in here, 4 in here, 5 in here, and 6 in there? Let's say. Think with me for a second. How many are in circle Z? Well, 7. Circle Z is 7. How many are in circle Y? 9. Notice how we counted the middle twice there? So that's why we have to subtract the middle, the 4, because we counted it twice. If all we want is to know how many in the union, which will be 12. Is that too quick? Do you see that logically? The left side is the union, right? It's either in Z or in Y. That's what the U means. You're not Z and Y. You're either in Z or in Y. How many are in either Z or Y? Well, 3, 4, 5. Right? 3 plus 4 plus 5. right? This is 3 plus 4 plus 5, which is 12, right? 3, 4, and 5 are in either z or y. And how could you figure that out on the right side? You could take all of z and all of y, but you're counting the middle twice, so you got to subtract out the middle, so you only get it once. Do you see why that formula is true? Do you see how that formula is going to always hold true? The union, which is these three things together, is going to be all of z plus all of y, but then you've counted the middle twice, minus the middle once, so you only get the middle once. You see that? That's why that formula is true. The union is z and y individual minus the overlap, because when you do z and y, you've counted the overlap twice. You counted it once for z, once for y. You've counted the middle twice. So you got to subtract the middle to only get everything once, which is what union is, everything once. That's what union is, everything once. How we do? I just keep saying it. I'm looking for. Like, yeah, that makes sense. But don't do that if you don't really feel that. But I'm not. Keep thinking on that. There are many things I heard in math classes and didn't make sense to me, but I would keep saying them to myself later as I'm doing the homework, and I'd ask the teacher, and I'd ask people. Finally, they'd sink in. So maybe that's one of those things. Think how that is. So I'll say it one more time. We'll move on. The union is everybody wants, not the outside. We're not talking about the outside, right? Just the 3, 4, and 5. Everybody in a circle once. That's circle Z united with circle Y. What's everybody once going to equal? All of z and all of y, but then you've counted the middle twice, subtract the middle once. Okay, so how do we use that then? Because I don't have 3, 4, 5 or whatever, those are just made up numbers. So we can get rid of that. That was just me showing that it's true. How do you actually do this problem? Well, they're saying the union is 0.74. That's what they're telling me. The union is 0.74. And z alone is 0.52. And y alone is 0.41. And this, call that x or whatever. It's the overlap. Solve that equation for x. It's in the middle. It's the overlap. Do you see how I just converted that formula, plugged in the three numbers they gave me, and the one thing I'm looking for as x, the overlap. I need the overlap, don't I? They didn't give me the overlap. I'm going to have to get the overlap myself using this handy-dandy formula. It's handy and it's dandy. You good? Now, you good solving algebraic equations? Let's solve it. Oh, it's a 0.93 minus x. All right. X is saying, I want to be alone. So what do we do to get x alone? I'm just going to get rid of that 0.93, right? And so that'll be negative 0.21. And this is negative on the x also. So that just means x is regular 0.21, right? The two negatives cancel on both sides. X is 0.21. So what? So we found the middle. Now we can do everything. We found the middle. The middle is 0.21. Isn't it? The middle is 0.21. The overlap is 0.21. We use that formula. So you want to put that formula on your 3x5 card, and you use it when there's no overlap given. When you don't know the middle. That's what you want to use it for. Put it on your 3x5 card and use it when you don't know the middle. So we found the middle, 0.21. Now we can do the rest. Can you do the rest of the problem? So find the rest of z and y and the outside and see if you can finish it up. And then answer the first question. So first finish the Venn diagram. Get the other three sections of the Venn. Doing good in the rest. I'm going to jump in. Z is 0.52, so 0.52, subtract the middle. 0.21 leaves 3.1.
How did you get 20?
Yeah.
But I got 19.
Oh, did I do the wrong thing?
Yeah. It's 19.
Oh, thanks. Sorry. You got to tell me that a long time ago. You're just thinking the teacher's not wrong. No, I make dumb mistakes. Thank you. You're right. That's 19. I was testing you. Good job. Thanks. Sorry. 0.19. That's going to change everything, huh? Let's try that again. So 0.19. And all this is going to change over here. Thank you. So 0.52 minus 0.19. 33? I won't trust my own calculations anymore. 0.33. And then do the y part there. What's the y? 0.41. 22. Like that. Good. Then how do we find the outside? Add them up, subtract from 1, huh? Right? So 1 minus these 3 added. Minus point.
We already told you.
Yeah, they told us 0.74 right up here. Good eye. You're thinking well. You could just grab it right there. They told us what the union is. So it's 0.26 out there, right? Good. Now we have the entire Venn diagram. Now bring on the questions. Now we're ready for them. Right, let's do the first question. Here it is. See if you can do that. So remember whether that's a U or a U turned over, what that means. It's either both and or either or. Make sure you're clear on that. Which way does the scholarship read? All right, it says not in Z. It's both. It's both and, huh? Right? It's both. It's overlap. You got to do both. Both not Z and not Y. So what numbers are both not in Z and they're not in Y? 0.26. Done. That's it. 0.26. And I'm going to skip the rest. Is that okay? The rest, well, let's do one more. Having said that, I want to do one more. So this is 0.26. All right, let's do one more that I think will be beneficial. Then I'll move on. I'm not going to get through many questions today, but I'll do well the ones we've done. So the next one, right there. So Z bar, Z prime, however you want to say that, not Z. Unite. So that's the second one. Try that one. That's to get the symbol the other way now, don't they? See the second one? See if you can do that. Are we expecting that to be a lot or a little? A lot. Unions are always a lot, aren't they? Overlaps are very few. This is saying either or, isn't it? You agree with that? That's what unite means. When groups unite, people come together from either group, don't they? Either. Either not Z or not Y. So which ones up there are either not in Z or they're not in Y? Everybody but the middle. Do you see that? This guy, this guy, this guy. Everybody but the middle. Everybody but the middle is either not in one of them or not in the other. Is that making sense? The only people that can't say that is the point 19 because they're in both. Everybody else is either not in one of the circles or not in the other. Right? So, point 33 plus point 22 plus point 26. I have no idea what that is. Oh, it's probably point 81. I just did 1 minus point 19. So, there we go. Good. And the rest of the parts are similar. All right. So these are tricky. You want to work through. We're only on question 8. We got 50 easier. Those Venn diagram ones are the challenging. All right. You're rolling a 2. So if you're going to roll a single die, they're asking me odds. Let me start with probability. What's the probability of getting a 2? 1 out of 6, right? Just 1 out of 6 numbers. Now remember, how do you go to odds then? Remember what we talked about? Maybe not so much. Probability is 4 over total, that you know. The number 4. Odds is 4 to against. So the difference between odds and probability, again, probability is 4 over total. Odds is 4 against. So odds is like a debate. Like we had a debate in here and 10 people feel this way and 6 people feel that way or whatever, 2 different sides. Right? Whereas probability is 4 in total. So they both start with 4, don't they? They both start the same. This will be 1. They start the top and the front are the same. The difference is how they finish. The difference is how they finish. Probability finishes with total. So one person is for an issue out of 6 total. So how many must be against it? 5, huh? Yeah. Everybody good with that? Odds is just 4 and against. Probability is 4 total. So if you said, okay, we had 6 people total in a room and 1 was for a certain issue, then you'd say 1 out of 6 are for that issue. And you want to convert that to odds, it's 4 and against. One person is for, and 5 must be against the issue. Does that make sense? It's the only difference between odds and probability. There's not going to be much odds on the test. You'll see that in the practice exam. I think it's kind of a dumb thing. I mean, who cares? It's so small, such a small difference. I don't think it's very important. There it is, 1 to 5. Okay, I always start with probability. What is in red? All right, so we got 5 red, 4 yellow, 3 green. You know probability, total on the bottom, 4 on the top. How many total marbles? 12, 5, 4, and 3 is 12. How many are red? 5. So the probability would be 5 twelfths. What are the odds? So we have something to something. 5, yeah. Because they always start the same, don't they? Odds and probability start the same. So if there's 12 people total in the room, 5 or 4 at issue, how many over here is going to be against the issue? How many against it? Must be 7. 12 people total. Good enough? 5 to 7? Odds is 4 and against. Probability just has total. Good. Other day, right? Remember that thing? You haven't been able to think about anything else for the last 5 days. I'm just kidding. So I'll just kind of do part of it here. So this, when you roll 2 dice, you want to have this on your 3x5 card. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. I'm going to do the whole thing. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2. 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. There's everything that can happen when you roll 2 dice, right? 36 different results. So whenever they say roll 2 dice, use that. All right, now what do they talk about in particular? Sum of 9. Which one's sum? Remember, those are diagonals. Remember we talked about any total's a diagonal. So that's it's this diagonal right here, isn't it? All those have a sum equal to 9, don't they? 6, 3, 5, 4, 4, 5, 3, 6. And how many have a sum of 11? That's these two right there. Sum 11. So the probability then, 36 is the bottom, total. How many? 6. There's 6 different boxes. 1, 2, 3, 4, 5. 6 different results out of 36, which reduces to be 1/6, doesn't it? For probability. But they're asking me odds. So I always start probably then odds. So if the probability is 4 over total, 1 to 6, what are the odds going to be for and against? 1 to 5, done. 1 to 5. So the chances that you're going to get a sum of 9 or 11 when you roll 2 dice is 1 out of 6, meaning one result is for you, 5 are against you. So if you play dice games, now you know calculate the probabilities of things.
Show up the chart.
What's that?
You're going to show up with the chart.
That's right. Got to have the chart. Yeah, that's right. We do some of this in our family. We're, I'm sure, a little bit of a strange family. My wife and I both have math degrees, and my oldest son will finish his math degree in December. And so but I'm really the most nerdy one that actually wants to, no, there are odds of that. And the other one's like, whatever, Dad. I'm just rolling. I'm just trying to do the guess thing. But anyway, I always like to bring the probabilities. Okay, so now notice we're starting with odds. The odds are 7, 3. Sometimes they put a colon in the middle. Sometimes they put the word 2. No, it's just whatever. It's just like a sideways fraction, huh? It's no big deal. Okay, but remember, this is for and this is against because it's odds. And they want me to change, to going the other way, they want me to go to probability. So it starts the same, right? They start the same. What's the bottom's going to be the total? So what goes in the bottom? 10, done. It's easy, right? Just go backwards. Not good? So I started with odds, went to probability. All right, I'll move on. Okay, they're going to give me these tables, and they say, here's all you really need. You don't need all these words. Blah, 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 blah. Who cares? Probability, single parent, woman is a woman in the Air Force. That's all you need. Is the table and those and this right here. That's all you need. So you got this table. You're going to pick somebody at random out of that group. What's the chance they're going to be a woman in the Air Force? Well, and they're saying probability. So probability always means totals on the bottom, right? So what's total? Well, there it is, 88. 88 people total, huh? That's easy enough. So all we got to do is the top. We want women Air Force. How many is that?
6.
Right here, yeah. Female Air Force, 6. Just reduce that fraction. Divided by 2. Set 3/44. Done. Good enough. Not too bad. I move on from that one. We good? Try another. All right, so this one, same table, blah, blah, blah. Who cares? It just says in the Air Force. That's all they say. Nothing about male, female, whatever. Just what's the chance? Probability. They're in the Air Force. Probability. Total on the bottom. That's still 88, right? So how many in the Air Force? Air Force, yeah, 17. Done. That makes sense? It's all the Air Force people now, not just the females in the Air Force like the last one. These are easy, right? These will be the hard ones are the Venn diagram ones, right? These ones are by far easier, so I want to spend time there. Keep moving. All right. Military, Marine Corps or Navy. So again, it's probability. So you know what goes in the bottom is total, which is in this case 102. Okay. Marine Corps or the Navy. So what's that mean? What do I do? 10 and 33. So that's 43 over 102. Good? That's all the people in the Marine Corps or the Navy. All is well? So far, so good? Okay. 100 people about their music expenditures gave the following information, blah, blah, blah. Give it a try. Let me let you do it. We'll be diving in. We've only got 3 minutes. Well. What tool do you need for this job? Venn diagram. You see, it's not a tree, it's 2 characteristics. Classical music, seniors. And there's not options there. You're not like different kinds of seniors or different kinds of classical music. It's just, you like classical music or not, or you actually bought classical music or not, and you were a senior or not. Right? 2 box with 2 circles, Venn diagram. So classical music, senior. We need the overlap, right? We need the overlap. Do they give me the overlap? Is there anywhere that's telling me what's in both?
Seniors who bought classical music.
Yeah, good eye. Right here, 22 were seniors who bought classical. That means they're both. That's the middle. Everybody seeing that? They are seniors and they bought classical music. They're both. So you start with the overlap and then work your way backwards by subtraction. So now we can do it. 39 bought classical music, so 39 minus 22 is 17 there. Good. 28 were seniors. 28 minus 22. 6 are here. How do you know the outside? 100 people total. Yeah, so is that up there? 100 people were surveyed. So add those all up, subtract from 100. So 100 minus 17 plus 22 plus 6. Whatever that is, 39, 45. Is it 55? I did it quick, is that right? Did I do the math right? 55? 55 out there. Okay, now we can answer now once you have the Venn diagram, all 4 sections, now you're ready to answer the questions. Here we go. The probability is a senior who bought non-classical music. Senior non-classical. Which one's that?
Just senior, 6.
It's these 6. Right? Why? Because they're not in the classical circle. They did not buy classical music. And they are seniors. It's not the 55, because these 55 aren't even seniors. They're not even in the senior circle. They asked me for seniors who bought non-classical. That's the 6, isn't it? So that's 6 out of what? 6 out of 100. There's 100 total. Probability is always total on the bottom. That's why I got 0.06 decimal. We're out of time, but the rest are like that. Just keep going on.